In today's lesson, we are going to be covering percents. In order to discuss percents, we are going to look at ratios and fractions and see how they compare to a percentage. So the first thing we're going to do is we're going to look at the definition of that. So the definition of a percent is a number or ratio expressed out of a fraction of 100. And in order to do this, we are going to be using 100 squares. This is just a square that has 100 blocks in it to represent every single percentage that would make up one whole. So for example, let's say that you were creating a Lego set. It's of a car, and it's going to take 100 pieces. That's how many there are in the box to create the car. You cannot say that that one car is complete until you have placed that 100th piece of Lego into your set that you were creating or the car that you were creating. So that means that you would have 100% of the car done when you put that 100th piece and you snap it into place. One last thing that I want to cover before we get started, percent. Cent actually means, if we look at the root word definition, it actually means 100. So percent is actually per 100, and that's why we're using this 100 square. So in our first example, we are going to show 1%. Okay, if we're looking at what 1% actually means, and we look at that definition we came up with per 100, we would have 1 per 100 squares. So if I had 1 out of the 100 squares that are here, I would just have 1, and I'm going to choose the one in the corner. I'm going to shade this in. This would be 1% of this entire whole. Now, if we were to write a fraction that would represent the green shaded area right here, okay, well, how many total squares are there? There are 100. That would be my denominator. So 1% is actually equal to, remember, out of 100. And how many of them do we actually have? Well, we have 1 out of 100. And we put this right here. So this is a percent, and here is a fraction. Remember, we can also write a ratio in fraction notation, and it would look exactly like this. So this is why we say that percents, ratios, fractions are all interconnected. There's one more thing that I want to go over and cover before we move on to a new percentage, is we've got 1% here. This was 1 out of 100. Now, if I wanted to find a decimal equivalent to this, I could do that by taking or doing this division problem, 1 divided by 100. So here we do 1 divided by 100, and you can see that we'll get 1/100th. And this would be our decimal equivalent to 1%, or you can see 1/100th. It's in the name of this fraction, 0 and 1/100th. There's a reason that we named these hundredths and tenths and thousandths. In this case, we had 1/100th, 1/100th, 1 out of 100, or 1 per 100, 1%. Now in our next example, we're going to examine 5%. Remember, in our first example, we did 1%. So we shaded 1 out of 100 squares. This time we have 5%, so we're going to shade 5 out of 100 squares. Let's go ahead and shade those. 1, 2, 3, 4, 5. So this shows 5% visually. If we were to write a ratio of number of shaded squares to the total number of squares, that would give us our fraction for 5%. So let's go ahead and do that. How many total squares are there? Has not changed since last time. There are 100 of them. All right. Okay, so how many of them are shaded? 5. 5 out of 100. That's equal to 5%. Now, last time, there was no way to simplify this. 5% is not always represented by 5 out of 100. Both of these tops and the bottoms of this fraction are divisible by 5. If I divide the top and the bottom here by 5, to make an equivalent fraction, we would get 1 out of 20. All right, let's go ahead and see if these two fractions, both 5 out of 100 and 1 out of 20, are equivalent to one another. Let's go ahead and see what our decimal equivalent is for this fraction or for this percent. So we head back to our calculator. We're starting off with 5 divided by 100. We get 5 hundredths as our decimal equivalent. Okay, let's try the other one. 1 divided by 20, which was our equivalent fraction, and we got 5 hundredths. So all of these things are equivalent. We've got 5%. We can write it as a fraction, 5 hundredths, or we could write it as 1/20th when we simplified it, or we can write it as the decimal, which would be 5 hundredths. Now let's check out 10%. We're going to do this a little bit quicker this time. 10%. So we're going to shade 10 out of the 100 squares, 10 per 100. So I'm going to shade one whole column here. I have 10 out of 100. And also what we can assume here, so if we look at how many columns there are in this graph or in this chart, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It might help if I label this, right? 3, 4, 5, 6, 7, 8, 9, 10. So what fraction could I write if I look at this chart? If I've shaded one whole column out of how many columns that there are, I could find a fraction that is equivalent to 10%. If you said 1/10, you would be correct. So this is actually 1/10. We have one shaded column out of the 10 that exist in my 100 square. Sorry, you can't see that perfectly. Let me pull this down a little bit here. And we could also write this as related to 100. Remember, we have 10 out of 100. So an equivalent fraction to this would actually be 10 out of 100. We could go ahead and divide that. 10 divided by 100, or 1 divided by 10. And we would find that our decimal equivalent here would be 1/10. And if we look at that, we say 1/10. We say, when we say this fraction, 1/10. Okay, there's a reason that we called those tenths, hundredths, thousandths. So these are the three problems that we have covered so far: 1%, 5%, and 10%. I want us to really focus on that decimal equivalent and how we can take a percent and write a decimal right away. If we want to go from percents to decimals, we're going to divide the percent by 100. So if we have 1%, we are going to do 1 divided by 100. A simple way for us to do this is to think about powers of 10 and what would happen when we divide by 100 or divide by 10 2 times. Well, what would happen is, okay, if we imagine that we had a decimal point, okay, here's my 1%. If I divide by 10, I would have 1/10. And if I divide by 100, I would move to the left twice, fill in my gaps there, and my decimal would be right there, which is 1/100th. Same thing would go for 5%. 5 divided by 100, 5 hundredths. 10% would be 10 divided by 100. We move our decimal point twice. We don't have to fill in any blank swoops here, and we would have 1/10 or 10 hundredths. Now, if we want to move in the opposite direction, say we want to go from decimals to percents, we're going to multiply our decimal by 100, or it means that we're going to move our decimal point to the right 2 digits. So, for example, if we were taking 5%, we multiply by 100. That means our decimal point is going to move 2 digits to the right. And now we would be over here, and this is my percentage, which would be 5%. That 0 in front of the 5 has no value, so we just have 5%. Next, we would look at 1/10 or 10 hundredths. Okay, we're going to apply the same logic and reasoning here. We move our decimal to the right twice when we multiply by 100. So we multiply this by 100, we would move our decimal point twice. We would be left with 10%. Okay, the answer is not 10, it's 10%, 10 out of 100. And our last one, we have 83 hundredths here. We would multiply that by 10, moving our decimal point twice to the right. We would have 83%. In some cases, you might have a decimal that looks like this. Here we have more than one. We have 1 and 23 hundredths. So if we were to convert this to a percentage, we could do that. We just have to take a look at it. We would do the same exact thing. We would multiply this number times 100, okay, moving our decimal point twice, and we would have 123%, which would mean that you have one whole and 23% of another one. You might be asking yourself, when would I have more than 100% of something? You may have gotten more than 100% on a test before. How did this happen? Well, let's go ahead and take a look. Let's say that there was 20 questions on your test. Okay, there's 20 questions. And your teacher offered you 2 points of extra credit. How many could you get total? Well, if you got all the questions correctly, answered correctly, and you got the 2 points of extra credit, you would have gotten 22 points. Okay, well, my total number of points that I'm going to be grading on is out of 20. So you actually got 22 out of 20 questions correct, or you got 22 points out of 20. So this actually means that you got more than 100% of the points on the test. And we could go ahead and find this percentage. We could plug this into a calculator. What I'm going to do is I'm going to use my knowledge of numbers here, and I'm going to find my percentage by using equivalent fractions. I can multiply my top and my bottom here by 5. I'm not going to change the numbers, the ratio between the numbers. I just want to see how many I got right out of 100. Okay, if I can make my denominator 100, we can find the percentage. So I'm going to multiply my top and the bottom by 5. Let's go ahead and write that out. 22 over 20. I'm going to multiply top and the bottom by 5. I'm not really changing anything because if you remember, 5 over 5 is actually equal to 1. 22 times 5, 20 times 5 is 100. And 2 times 5 is 10. So this would be 110 out of 100% that I could have gotten. So here is actually my percentage. I got 110% on that test. We covered a lot in this video. Percents to decimals, decimals to percents, decimals to fractions, fractions to percents, all of those things. And they can all be used interchangeably, and they can all mean the same exact thing. They're all equal to one another. It's just a different way of writing them. So as always, use your math skills wisely. Have a good afternoon.